Hello, welcome to part two, so samples and feedback. In this, I'll be looking at samples of student work and the kind of feedback that's been given. So you might just have to bear with my computer. It can be a little bit slow sometimes, but there we go. All right, so this sample of work, nice and simple. This is a Year 7 Technologies classroom, and their job was to create a phone box. Now, it's quite simple. It's 4 separate pieces, all cut to length, and then a plywood base attached. After that, nailed together, putty to hide the nails, finish, and they're good to go. They also had an additional task where they were to laser cut a design and test it, and then afterwards they would make the lid using a laser cut. If I turn it backwards, there you go, the MC is facing the right way. So, this is my sample of it that I used to show the kids, but unfortunately I wasn't able to find any of the kids' samples as all of them were taken home because they enjoyed the project. Now, what areas of assessment did we use for this? Now, first of all, we used portfolios. So students were provided with a workbook and continuous questions and recording of progress. Now, what that meant is that basically they had to keep a track of where they were. There were always instructions as to what to do next in case they got lost. And there were just various questions following up with different terminologies, different methods used, getting the kids to record their progress and what they found interesting. Moving on, checklist. So, marking these. Now, I used a checklist of evaluation. So, quality of product. An example of this would be all of the pieces cut to shape. Because it's a square, well, a rectangle, these sides have to be the right size, so these, and then these two have to match as well. Beyond that, it doesn't matter too much because it can be cut down, but so long as they match, we can get a good, nice rectangle. That's the main quality of the product. Beyond that, if I wanted to check any assembly things, I could check the 90° on these. As these pieces here are not actually supported by anything, whereas these side ones are, as they press against it. So I could check to make sure that these are at a 90° angle. My one is slightly off, maybe by 1/4 millimeter on the top. And so that's something that I would look for. Quality of the finish. This uses a basic shellac finish with a wax on top of that. Makes it smell really good. But the quality of the finish will also depend on their sanding. Now, if they start low and then move high, they'll get a really nice, smooth finish. After applying the shellac, one sand, and then the wax. And you can actually tell in which stage if they've missed anything. So, if they've done everything exactly how they're meant to do, you'll get a very smooth finish to the box and a very nice chatoyancy inside the timber. Now, chatoyancy, if you didn't know, that just means the glossiness of the wood and the light being refracted inside it. Attention to detail. Certain things like their laser cut, if they actually find something online that they like, they can provide a vector file and we go through how to apply that and how they can find that. And then they need to work out which stages of their laser cut they're at next. So they need to laser cut the shape of the lid, the hole to stick their finger through, and also their logo. If they've kept their attention to detail, there should be no problems with it and everything should come out as it should. Now, we also use authentic tasks. So the authentic task, obviously, is this phone box. Does it hold a phone? If it does, there's a photo of my lovely wife. If it does, they have that authentic piece to take back with them. And that's also something that they can reference and use. Because it's a phone box, we can also get them to bring it to class. And if they ask, what will we use this for? It's like, well, you bring it to class, you put your phone in here, and then you don't have to worry about it during class. Now, another thing, observations, taking that time to actually keep an eye on students, see how they're working, what are they struggling with, what can they be assisted with, and how well they kind of pick up the product. What can be done better or change for students going forward? Now, it's a pretty good project, nice and simple for the kids. But something that you can do is give them a bit of variation to product. An example of this, instead of just nailing the joints together, you could use a miter joint where you sand it to 45 degrees, stick them together so you get a nice clean grain all the way around. That's another case of joinery and assembly. But to go further than that, variation of product in the laser cutting. Whenever you want, you can get them to design their own thing. They can do whatever they want. Now, they could make it so it's got cutouts, it's etched, it's entirely up to them. All right, moving on to part 3. So adjustments and required learning. At the school that I'm working at, we have a Year 7 class, and in that class that are doing this project, we have a student that has dwarfism. Now, it's pretty difficult to kind of manage a student with dwarfism in a technologies lab. The benches are too high, the machines are too high, everything's out of reach for the student when it comes to tools. So what's been happening is the student actually has a almost automated wheelchair, and we get her to get to where she needs to go, and we've also hired an SLSO. Now, this learning assistant, they help her out. They get her all the materials that she needs from the tool cabinet. And then on top of that, we have a mobile stand that we can kind of move to the machines. Now, what that means is that she can go from her wheelchair onto the stand and then actually have the machines and workbench at her height. She's found this really helpful, and it's meant that she's been able to engage with all these different technologies. And she's actually excelling in a lot of the digital technologies and design because she's gotten that hands-on experience. Now, another area that we need to be careful of is ADHD. Now, we've taken a lot of adjustments for a lot of the boys with ADHD, as some of them, if they're not careful, they can actually be quite dangerous. Now, a tech lab, you have multiple things that are sharp, such as chisels, even something like a set square. If a kid's really wanting to go for it, they can hurt someone with that. The way that we've been managing this is we've actually been monitoring them quite closely, and then when possible, giving them a task. Now, one of the best things that I've learned is a kid can't muck up if they're busy, as you're not going to have time to muck around if you're too busy trying to complete the work that's been given to you. Now, we don't want to swamp them. Obviously, if they have ADHD, it can be a bit of an overload and they'll just kind of meander. But once they finish a task, they come to us, we give them a new one. Responsibility is another. Now, when I'm introducing the class to the topic, I will actually provide them with timber. I might get one of those boys to come forward and to just take the timber to each of those students. Their job then is to make sure that every student gets one, they get their own one, and then they'll come back and I'll give them a different task. But we found that really helpful in just managing the boys and always making sure that they have something to do and aren't being a risk to anyone around them. All right, adjustments that are made for diverse learner students. Now, luckily in technologies, it's really easy to, adjust everything for students, especially in numeracy and literacy. In numeracy, we have our workbooks. We always have them doing their calculations, making sure everything's up to snuff. But it's actually really easy to show whether or not the student understands their application of knowledge because we have a physical product at the end of it. It'll look slightly off if anything's out, and you can always tell with a student if something's slightly off, like say 5 millimeters either side, that will show when they assemble it. Their conversion as well, we get them to convert a lot of different units, centimeters, which is what they normally use, to millimeters, which is our technical work, and the application of that. Now, when the students are measuring out, they have to measure 70. So we always check 70 what? What are you measuring? So they'll go, 70 centimeters. It's like, no, why do we measure that? And what is that actually? What is that in what we work with, which is millimeters? So we have our 70 millimeters. Then we need to add another 5 for the saw. And that's another point where we kind of check that understanding if the kids do that. Another thing, if their ruler is long enough, they'll go 70 and then 5. And then they'll go, that's 70. Obviously, my next line is at 140. And that will throw it off because they've actually added a 5 in the middle. And you can actually check that with the students. And a lot of them will go, of course, I missed this one little piece and it kind of threw all of it out of whack. And you can explain that that's a very common thing in technologies. If you're not taking every little measurement into account, you can actually change your product quite drastically. Now, literacy. Literacy is also easy. We have a workbook for them. It involves various things like investigating timbers and terminologies that are appropriate to the subject area. An example of this I gave earlier, which is chatoyancy. Now, again, chatoyancy, glossiness in the wood, and the way that the light refracts inside it. Now, How is that affected? What different types of finishes give chatoyancy? What kind of chatoyancy is preferred? How do you know if you want a light wood or a dark wood? These are all different things that kids can look for in their workbook. Now, I'm going to have to leave it there because I've gone over time, but thank you very much for watching my presentation. I'm sorry that it's a little bit late. I was quite busy working with the referendum, and I had quite a few very late nights. But again, thank you very much. Shane, if you're watching this, thank you for that extra little bit of time. I did kind of have to throw it all together at the last minute, but again, thank you. It's been a great subject.